Now the opposite, now it's interesting, there's another hormone released by alpha cells called glucagon. So glucagon frees your body's nutrient reserves into the blood. So this is what we have here, and hey, glucagon, it looks like another cartoon of it looking like a bunch of beads on a chain and all these amino acid names. And hey, it looks like a little ribbon right here. So it is a peptide because again, you have these chains of amino acids. So what does glucagon do? Well, we did talk about cortisol causing the increase in blood causing or stimulating gluconeogenesis in the liver. So that's what it does. But cortisol and glucagon work together. And how does that happen? Well, glucagon and cortisol, it tells what we see here, this corn-like stuff. This is white adipose tissue. And it's going to cause triglycerides to break down or stimulate the breakdown of triglycerides into another compound called glycerol. And glycerol can be used for gluconeogenesis. It also releases a lot of fatty acids, but I think I'm going to save that for the metabolism chapter, I think for exam 3. But either way, more glycerol. Glycerol can be easily converted or relatively easily converted into new glucose molecules. So now you have something else fueling this gluconeogenesis process. Now cortisol and glucagon, they also cause proteins in your muscle tissue to break down into amino acids. And amino acids are also something that can be scavenged and be used to fuel gluconeogenesis. So we have even more sources of carbon that can be converted into new glucose molecules. So what we have here, glucagon and cortisol are causing the breakdown of things and also causing the creation of new glucose molecules. And what happened over here? Did the blood concentrate or did the blood sugar go up or did it decrease as you have break down these tissues? Again, we started here, and as we had more and more gluconeogenesis, what happened to the blood sugar concentration? Yeah, so notice that glucagon and cortisol are working together to increase your blood sugar. So this is an interesting thing about glucagon and insulin. Not all hormones oppose each they're a classic example of two hormones that work opposite each other. So insulin lowers blood sugar and glucagon increases blood sugar. So there are several pairs of hormones in the body that work opposing each other. Insulin and glucagon are one of the classic pair. But yeah, that's a really cool thing about that. So instead of like how insulin is generally anabolic. Again, some endocrinologists and some other physiologists don't like that term. So insulin, it builds up glycogen, it builds up protein, it builds up triglycerides and adipose. Glucagon is going to stimulate the breakdown of glycogen. It's going to stimulate the breakdown of triglycerides and also stimulates the breakdown of proteins into amino acids. So in general, glucagon has catabolic effects, but why is it breaking down all these tissues and molecules? It's trying to release more nutrients into the bloodstream. So glucagon also, what is glucagon's overall effect on blood sugar? It increases blood sugar. And then we have a concept called glycemic index. So glycemic index is what we see here, high GI and low GI. So what is glycemic index? So it's a metric of how it ranks and rates foods based on how they affect your blood glucose. Like in that previous graph, we showed that during the day, your blood glucose spikes, it drops, and spikes, it drops. So that's why, like, every time your blood glucose goes up, you don't want it to stay elevated for a long time. So that's why you always have insulin secretion after you eat a big meal to bring your blood glucose back down to normal levels and store all that glucose and nutrients in your cells. But glycemic index, it rates it on how they affect blood glucose. So what they do is establish a baseline. So a GI of 100 is pure glucose, but with equivalent levels or equivalent amounts from other foods. So when we have a lower GI, notice that the blood glucose doesn't spike as high as something that's high glycemic index. And what they do is that they measure this area under the curve. So the shaded area that's below the curve that you see over time, they measure that and see what the area is. And for those of you who have taken calculus, that sounds familiar, right? So again, this is how some people are like, when will we ever use calculus? Well, if you're calculating glycemic index, you may have to use calculus. But so what we see here is the area under the curve, and this is like so you just basically take this area and notice that if you have a very high glycemic index, you're going to have more shaded area than something that's lower. But this is actually a diet instead. But again, yeah, this is a repeat of the previous one. All right, so then back to our glycemic index, and let's go to top hat. Next question. So which of these foods has the highest glycemic index? I'm going to show you 3 foods. So these are the 3 foods: white rice, brown rice, and a baked potato. So assume you have equal mass of each food. Which of these would have the highest glycemic index? So which would cause your blood sugar to spike the highest over like 1 or 2 hours? Okay, let's see what people said. Now, white rice, so seems most people think white rice has the highest glycemic index, and maybe second place baked potato, and nobody thought brown rice has the highest glycemic index. So let's find out the answer. Okay, so what we have here, and what I looked up is various glycemic index table. I just actually Googled glycemic index of starches or potatoes or rice, and I came up with 3. You'll find so many different charts. And just from this selection I had just by using Google search, yeah, what we see here are our candidates. So white rice in this one has 72, but brown rice is lowest. And whereas in this chart we see brown rice having a glycemic index of 55, white rice having a higher glycemic index. Whereas here, brown rice and white rice, well, it now says white rice has a glycemic index of 38. And how about potato? Well, it says higher in this one, but what about other things like baked potato, 85 and highest here, and baked potato is 85 and highest here. So, I mean, according to these, what we have here are sometimes the values don't even agree with each other. The number, like 100 will always be pure glucose, but does it rank compared to pure glucose? Well, we see different rankings and different values. I mean, this is pretty interesting. Like 38, that's really, really low. So this is my main thing with showing this, is that you have to kind of beware of the internet, especially when it comes to glycemic index. Like glycemic index is still a popular, I mean, it's probably been around for a while. I have to research more on the history, but there's it's always something being debated. It's it's not just about how much carbohydrates you eat. Now they're saying it's not just the whole weight of the carbohydrates, but also glycemic index. So it's a hot topic in research, especially when it refers to in relation to diabetes and obesity. So which of these has the highest glycemic index? So what's the answer to the question we just asked? Well, this is so where is a reliable GI chart? And this is what I had to look at. So what I did is look at one of the more powerful types of analyses, what we call a meta-analysis. And what this study did is look at, I forgot how many studies it looked at, but they looked at I should check how much, but this is a meta-analysis. Actually, let me check right now. But this one, yeah, it is a meta-analysis, so it's not just one study. It actually takes multiple studies. And this was in 2008, and this one actually used 205 articles. So it's not just one chart with all that we see on the internet. Actually took 205 peer-reviewed publications, went through all the, I think, how many foods? Yeah, 2,480 different foods, and then they basically did statistics, and they came up with statistical averages. And what we see here from this is that brown rice, okay, 68, white rice, a little higher glycemic index, and potato, it's about the same. I mean, it also is very interesting. Is it just a whole potato that's boiled, or do you mash it up? That seems to affect its release as well. And when we talk about digestion, you'll get a little more idea about why it can be the same food, but how you process it can also affect your glycemic index. Now, do I want you to memorize these values? Of course not, because look at how they vary between the different studies. But it's something you should know what glycemic index is and how it affects, what's the difference between a high glycemic index and low glycemic index food. Yeah. And actually, another thing that you see here, taro, boiled. So if you're like Poi, actually my grandma has type 2 diabetes, and she has type 1 and type 2 diabetes. She had type 1 first and then developed type 2. So her blood sugar used to spike all the time because she liked her rice, but she's also a local girl. So she had like, so once we got her on poi, she said we get poi from the market. Although she asks us to check the label every time because she doesn't like sour poi. But yeah, boiled taro, mashed up taro, and it has a pretty low glycemic index. And ever since she switched from white rice to taro, then that kind of helped her blood sugar stay a little more stable. I mean, she sometimes treats herself, but at least now she has a starch that won't cause her blood sugar to go haywire. And wouldn't these values depend heavily on people being tested on, so it wouldn't be too accurate. And that's another thing too. That's why meta-analyses, that's why the more people you have, the more the subjects, and this is why with these meta-analyses, sometimes they have to actually throw out studies because they say maybe their sampling of the population was too random or very limited to a specific population, or maybe they didn't have controls, or maybe the whole overall design of the study was flawed. So yeah, that's why it's very interesting. Like that's why glycemic index is a lot of research is being done because I think they're still trying to say like, okay, this is the standard way you should test glycemic index as well.